Hey everyone, I'm Derek from Apollo, and I want to chat about the benefits of developing your GraphQL servers using a code-first approach. And as I mentioned, I work at Apollo. I was leader in the GraphQL space. If you're using GraphQL at any scale, thinking about it, probably might be already using our stuff. Maybe you can check it out. I personally work in Apollo Federation, and that's our open architecture for building a distributed GraphQL APIs, right? So it allows you to compose a number of GraphQL servers into a single API that your clients can interact with. It has a tons of awesome features, but that's not the topic for today. So without further ado, going back to the GraphQL side of things, right? So GraphQL is awesome, right? It's a great piece of technology. It works awesome as this abstraction layer of all your different data sources, all right? So it's a single unified way to query all your data, regardless whether it comes from some underlying REST, gRPC databases, or whatever else, right? But we all know all about those good things, right? So the good thing about the GraphQL also is that, well, there are tons of implementations out there. There's basically implementation out there for every major language framework out there. And you can basically pick and choose the one that fits your stack, right? And when you're looking at those libraries, they will generally fall into those two categories, right? So we either do schema first or code first libraries, right? And what basically those categories mean is that basically they describe how you build your GraphQL servers, right? So with the schema first, you first write your schema file and then take it as an input to your GraphQL server, right? And then add a matching resolver code. And in the code first, well, you describe your schema using code, right? So if we're looking at an example here, right? This is a simple hello world example and implementation using Spring GraphQL, which is a great library. It's official Spring Boot module. And it's if you ever written any Spring Boot applications, this actually should look very familiar to you, right? So we have a controller class, right? And then we annotate the methods, right? So we have a query mapping on hello world. And this should look very similar because you would have like a REST mapping, like get mapping, post mappings, right? So it looks very similar, just different annotation there. And what's might not be obvious from this code example, because it's very simple, right? I'm looking at it, that, well, while it starts up very nicely and actually it runs, there is pretty severe bug in this code, right? Probably already noticed what is the problem here. But we're gonna get back to it in a second, right? So going back to the categorization there, right? Those categories. I personally think that calling it schema versus code first is very misleading, simply because you should always think about schema. It really doesn't matter whether you write your schema file by hand or you write code to describe your schema. You should always think about the schema because that's your API that the clients are going to be consuming, right? You want to build the best API for a client, so you should always design with a schema first mindset, right? So in my opinion, it's a better categorization for the SDL first, right? So schema definition language. So you write this schema file in this format versus the code first libraries, right? But there's also another caveat to it. So technically, any GraphQL library can be a code-first library, as long as you can write those very low-level GraphQL object representations, right, and build those abstract syntax trees. You get a code-first library, right? And a lot of the time, this is what people think that how the all the code-first libraries look like, right? So this is an example from GraphQL Java. So you can see it's very, very verbose, and I personally wouldn't really want to work with a code base like this. If it works for you, all the power to you, but I think there's actually a better way to do it, right? Which brings me to the crux of the talk, right? So this is the idiomatic code first libraries, right? And what I mean by idiomatic in this sense is that we're going to rely on our GraphQL libraries to provide us an abstraction of all those low-level nitty-gritty details about GraphQL and basically focus on the business logic itself, right? So the idea is that you write idiomatic code in the language of your choice, and that gets translated automatically to a corresponding GraphQL schema. So since we're going to be describing our GraphQL schema, well, let's take a look at a schema and see some of the characteristics of it, right? So this should be pretty obvious to you, but and this is an abridged version of like the Star Wars schema, right? That I put it over here, an example. But you can see that everything is typed, right? So strongly typed is pretty good characteristic, right? Then we have those different types and classes, right? So the types are kind of like classes. We have the types have fields. Some fields takes arguments, right? So those kind of like properties or functions in those classes to me. The next one is a big one, right? So everything has this exclamation or so every field declares whether it's null or not. So those were the exclamation mark at the end means, right? So GraphQL is null aware, and you have to define it at build time, right? This is a runtime validation constraint of GraphQL that's going to validate that those fields are going to be not null for you, right? Then we got polymorphism, right? We got interfaces and unions. We got enums. There is also like the built-in documentation in the schema. And last but not least, we also have, the directives, right? So they allow you to modify the behavior of GraphQL server at runtime based on some constraints. So like example is adding a deprecation information. Maybe you want to add some authentication, validation, any of those, right? You can add those directly to your schema. So ideally, our GraphQL framework of choice should have all those characteristics. And well, in the examples today, I am actually going to be using the library that does that. So today I'm going to be using GraphQL Kotlin from Expedia Group, which I actually helped write a while back, which is an idiomatic code first library. And how it actually works is that it uses reflections to generate your GraphQL schema directly from your Kotlin code. If you never used Kotlin before, for our intents and purposes, well, we're going to be running it on JVM. It's a GraphQL server running on JVM. And as such, we can think about Kotlin as a better, more modern version of Java that basically gives you full interoperability with it. You can use all your libraries as they were, but you get some extra superpowers built in because of Kotlin, right? So going back to our simple hello world example, on the left, we got our schema file, right? This is for illustration purposes because it doesn't really exist in our code base. On the right, we have example implementation of this query, right? So it looks very similar to what we had before with Spring GraphQL. So again, you still mark your classes as components. So they are beans in Spring context, right? We have an extra thing that we do over here is we implement a marker interface to indicate that this is our entry point to a schema. And then we have functions, right? So we get hello world function that takes an optional argument and returns us a string that is not null, right? So if you notice the difference between this example and this Spring GraphQL example, that's the difference, right? So here we are specifying that we have an argument, that optional argument, and in the Spring example over there was not, even though the schema declared it and the server started without any problems, right? But this is like a very just hello world, right? So looking at some other examples, right? So if we try to implement some of that logic from that Star Wars schema, right? You can see we just write functions returning data. So we get our heroes function, right? It takes a list of that takes an episode and returns a list of characters. characters, an interface, right? It's just functions returning data. There's nothing special about it, right? It's just how we write code, and for for a very, very long time, there's nothing special about it. But since we have a full control over our data, we also can make a distinction of how the data is being fetched, right? So at the bottom, right, we have an example of how the same GraphQL type can be implemented, but this will have a pretty big repercussions on the runtime. So the top one, right, it's just a data class, which means that in order to construct it, we need to basically pass both the name and home planet there, right? So we always have to compute those and in order to return this, right? But with GraphQL, clients don't have to ask for both of those elements, right? They can ask just for one. And in the case that home planet information is some heavy, heavy call to some underlying system that takes like a minute to return, well, the first one is going to spend a minute to return your human, regardless whether you need that field or not, right? So an example on the bottom, I just moved the home planet from a property to a function. And furthermore, I made it asynchronous by using the Kotlin superpower, the coroutines, the suspend fun. That's what it is, how you can identify it as a coroutine. And this makes it fully asynchronous, and the home planet is only going to be fetched when the folks actually ask for it, right? So this brings me to like the first benefit of doing that in the code first, and I would say it's just developer experience, right? So as I said, you write functions returning data. This is something that we've been doing for a very, very long time, right? There's no magic there. It's very easy to onboard folks to your project. It's very easy to folks understand what's happening over there. It's just functions returning data, right? And because it's just functions returning data, well, it's also very easy to test, right? You don't need the whole like big integration test to start up your app in order to run your GraphQL queries. You can write unit tests that verify the individual behavior, right? You should definitely still have some integration tests to verify all that stuff fits together nicely, but you can go very far with just unit tests in this situation. But as I mentioned before, we have also quite a few other characteristics of GraphQL that would be nice to express it, right? So looking at some other examples, right? On the GraphQL schemas, right, we can provide some documentation there, right? So if you're using the SDL first approach, that's generally just going to live in your schema, because otherwise you're just going to be repeating yourself in the code. Maybe you do, maybe you don't. And unfortunately, due to, the JVM limitations, the Java.docs comments are not available in runtime. So we cannot just use Java.docs comments, but we can enhance our models by using annotations. So I can do at GraphQL description and provide all this fancy comments and logic there, right? It supports Markdown, so you can do lists, bolds, whatever, right? The sky is the limit. Whatever you can put in your GraphQL schema, you can put in those descriptions, right? It's just a string with whatever data you put in there. And similarly, this is the way that you do the directives, right? So in GraphQL schema, right, you can apply those directives in those different locations. In code, you, again, just apply annotation. And here I'm using actual Kotlin built-in deprecated annotation, which translates to corresponding GraphQL deprecation as well. If you want to build a custom directives, it's a similar approach. You build a custom annotations, just apply it on the functions and classes or whatever else they're applicable, right? And this resides right next to your code where you actually specifying that, right? It's no longer checking against your schema file and your code whether there's actually anything else happening around that resolver. And this also brings us another interesting characteristic that your schema is generally not going to be static, right? You're going to be evolving it over time, right? So maybe you want to add a new field, right? Or maybe you want to change some return types or arguments or add new arguments or any of those, right? And since our schema is derived from the code, it's not possible to update your schema without having corresponding resolver logic, right? So I need to define in the schema in order to be, I need to define in the code in order to be actually present in the schema, right? It's not possible to update your schema and just deploy it without corresponding resolver, which is a possibility. So this brings me to a point that, well, doing an idiomatic code first gives you a single source of truth of data, right? So the code is your single source of truth. Whatever you write in the code, that's how it's going to behave. There's no magic there, right? Well, you may have some bugs, but everything, if it's working correctly, that's the behavior that you would expect. And there's also another interesting superpower, I guess, from Kotlin itself, right? So I get a snapshot here from Java on the left and Kotlin on the right. So it's a same query, right? I got a character query that takes ID as an argument and returns a character type, right? Java by itself doesn't have a concept of null versus not null. All the objects are nullable by default. So the code on the left, well, it could be valid, it could be not. I don't know whether this is actually the character query here should return nullable character or not. And if the schema says it's not null and you return null, well, GraphQL engine is going to catch it for you, right? It's going to coerce the value, going to give you, error message, and it's not going to blow up. It's still going to run, right? But it's a runtime error, right? On the right, the Kotlin code here. Well, Kotlin has a built-in concept about nullability, right? It knows when you define a field, you have to tell it whether it's nullable or not. Same as in GraphQL, right? So in Kotlin, by default, everything is not null, and you have to explicitly opt into nullability, right? So, and since I'm returning a character, it means that it has to be non-null. If there will be a character of a question mark at the end, it means that it's actually a nullable character, right? So the interesting side effect of this is that I cannot return null from this function at all. It's actually, IDE is going to tell me that this is actually a compile time error, right? I won't be able to build it. I won't be able to deploy it. So I need to fix it before my code goes into production. So I get the biggest benefit of all, well, I get a compile time safety. So catching bugs in production, well, as I said, well, it's going to run, but you're going to have those errors, right? If you can catch those errors before you get to the production, well, you save a lot of money, you save a lot of time there, right? But well, schema is actually great, right? Schema file is pretty awesome, right? It's a good tool for communicating some changes, like collaborating on the changes on the shape of the schema. There's lots of tooling around it, like maybe you're using something like a schema registry to detect breaking changes, right? So to see whether any changes to it is going to break any of the existing clients. And the good news is that you can still use it. So you can still use schema to collaboratively design your schemas, how they're going to be, looking at it, right? Just basically implement it in code, then that becomes your source of truth versus the schema, right? And furthermore, the schema can be generated at build time. That's your build time artifact. So when you're deploying your application, you're building your deployables, jars, or whatever, right? You can have an artifact next to it that is going to be your GraphQL schema that you can still use for all the other tooling that you're using there, right? But it also has a side effect that you will get the actually complete schema, right? And what I mean by complete schema is that if you rely on some third-party libraries to provide you some additional functionality to it, right? So, for example, maybe you're using Relay, which maybe you want to auto-generate all those different pagination and edges and all that stuff, right? So maybe the library just annotate parts of your schema saying, hey, I want to have it paginated or something, right? And it's just going to give you that. That's not the schema that your client is going to be using. It's actually schema is going to be transformed to something that the clients will see. Similarly, if using like Apollo Federation, there's going to be some additional directive definitions. There's going to be some additional queries added to your schema, right? So this is not the schema that your clients will actually see. If you generate your schema at build time, you're always guaranteed to have the final schema that the clients will actually use. And this will also, detect if there is something changes in your whatever library, right? So you haven't changed your schema, but you updated your package dependency in one of those other third parties, right? And then your schema changed. So what happened? This actually tells you right away, well, that's what's the difference there, right? And this basically, brings up all the points that I want to make. And the TLDR is, I would say, use schema for whatever it makes sense to do it, right? Use it for collaborations, use it for, the other tooling that you require to detect breaking changes. But next time that you're actually building your GraphQL server, do a code first and, still get all those other benefits and still get the benefits from the schema as well. So thanks.